let's take a look at the simple Swift data types. So Swift, like a lot of languages, has a string type and it has a number type. And we'll see what that is. Instead of number, they call it int or double or float. So Swift can do something called type inference, where if you don't even put the type, it'll go ahead and guess what it is. You could explicitly put the type if you wanted to, but you don't necessarily have to. So if I don't put it in there, I've got to print out the string. We'll see down here it prints out the value. And over here, I'm going to go and use this type operator. So Swift is strongly typed. That means at compile time, it'll go through each variable and make sure that the variables that are being compared are of the same type and the variables are being passed are of the same type. So we can see here it does infer it's a string. So Swift knows how to recognize something in these quotes. And then a freestanding number, we can print out what that is. And we'll see for that freestanding number, the Swift also does know that's an int. So you might say, well, can I do something like if what am I is equivalent to what are you? Do you think that'll work? And we can see it doesn't compile. Let's try it here. And here it gives us a message. It says equal has a partially matched parameter list. And what it's saying is these are not the same type. Let's change this to the number 55. Again, they're still not the same type. So like in some language, like JavaScript, it might be able to compare numbers. Here we can't, so we're going to have to cast one of these into a string and one of these into a number. So let's cast this first one into an int, since we know the type is int we're working with. And then we can have these two integers, two ints compared. And here they're the same thing. So we can see as integers, they're the same thing. And maybe as interestingly, let's see if we can turn this into a string. So we'll use the dot description for the int, and it has a method to tell us it's the same. So here we'll see for strings in Swift, it actually does do a lexical compare. So it looks at the characters. So these are different objects, but they are the same string. So there we are. These types are inferred. We could even cast a string into a double or another type. And we'll see here we have a decimal number. Let's find out what that decimal number is. Well, before we do that, let's look at this double. So this double, I was trying to print out the description of it. And here we can see it's not sure that this is actually a valid number, because sometimes, what if we put in something here? That's not actually a valid number. So would it work? Since it's not sure, we'll go ahead and force the compiler to know, hey, we guarantee that what we put in here as a string is actually going to work, and we're actually going to have a number here. And that's what this exclamation point does. It actually guarantees it. So here we can see it's print out. It did print out the 45. Since it's double, it gave us the decimal here. Let's look at this last one that has a decimal and see what type is it. So this last one is also a double. So we'll see that the two fundamental types for inherent types for Swift are string and double, but we can do other types if we wanted to. So we could do var. We could do a float number here. Identity. So this demarks the end of the floats. And then we can print out that type. We'll see that if we put it in there explicitly, it becomes a float. And there's other types we can do in here. We could so if we had some certain number of computer words we wanted to represent or a certain number of bits, we could make it a certain type. Like we could make it unsigned int. So there's support for these kind of types, different word sizes. And so we could do that if we explicitly wanted to, maybe if we're doing a bit vector or something. But in general, we're just going to go to an int or a double or a string. We can also, especially in the older versions of Swift, loop through what's in the string. So we could say we could go through the characters in the character array. So the what am I? So this is a string, but it has within it a set of characters. And then we could print out these characters. And this print will go ahead and give a new line, so we'll see it print them all out vertically here. So after each character gives a new line. So that's a way of going through the string. In Swift 4, we don't even have to use the characters property. And we just briefly touched on something called the optional. But if we come here, remember I told explicitly to make that an optional value. And so here it says, this says optional. If you ever see this value of optional type, not unwrapped, that just means the compiler doesn't know if you intentionally did this or was an accident. Are you positive this is going to be valid or not? And you can put the exclamation and just say, hey, I'm positive. And there's some other syntaxes we'll look at in some videos on optionals. That's the basic strings, basic different types, int values. Not a whole lot more to cover as far as the basics. We talked about type safety, so it checks the types. And an important thing to realize is that these basic types are passed by value. And so basically a copy of them is made. So if we were to have a method, we have a function where we pass in the value. It's kind of a simple one, but let's have a method here. Just have it not return something for now. And then we'll just say, we're going to do like this, and then we're going to say, does it even allow me to do this? And we're going to go and check it, and it's going to say, you can't assign a value, it's a let constant. So you can see right away that a copy is passed in, you can't change it. And so for these basic types, it makes a copy, and for the classes, if you create your own class, it'll pass in a reference. So you can change what's in that class. I guess one more. That's pretty much it for types. You can, of course, go and research a little bit more about it and find out kind of the additional properties they have. Like the max could be this greatest max value. And comment this out, command / So you could do this to get the greatest max value, or you could do the float max. Let's see, what is it? Max float, sorry. So these go back into the into the old Objective-C code. So we could go back and look at the Objective-C code and see how they worked in Objective-C. And here we'll see that, if we look one of these up, control, click on it and go to the definition, we'll see it actually is a float. So it's not just a number, it's actually a float type. So these actually map into the values in Objective-C. But so we have the strings, integers, doubles, but you could also work with more specific types if you wanted to. We have characters, signed and unsigned ints, and just like in a lot of other languages. That's it.